Okay, this power plant is equipped with a heat recovery system. We're going to go through some of the components of this. This is a three-way thermostatic valve. It's often called an AMOT valve. What this valve does is basically it has internal elements that mix coolant to maintain a constant 185-degree return temperature to the engine. So the hot coolant coming from the engines, if we're using enough waste heat to keep the system down to temperature, it'll come straight through the valve, go right back to the engines. As the temperature begins to climb, it'll divert coolant through the radiators, come back through the opposite port, and then go back to the engine. So this is a device that just operates on its own. There's no control function required. There's no maintenance really required on it. It just sits there and operates. And the three valves are provided to isolate it if it needs to be serviced. These are all normally open. Then over here we have a normally closed bypass valve, and this will typically be labeled with a tag that actually says normally closed, open only on high coolant temperature alarm. So if this mixing valve were to ever fail for some reason and you couldn't get the coolant to go through the radiators, what you would have to do is come in and valve off this one and then open the bypass valve. And what that'll do is get full flow going through the radiators and give us full cooling. And that allows you to keep the system online, and then this can be valved off, taken out, and repaired or replaced as required. So I'll return these valves to their normal position. Now the next part of the heat recovery system is a heat exchanger. This heat exchanger separates the coolant for the engine glycol cooling system from the piping that goes out of the building to the place where the heat is delivered to. So that way if we have a failure of the piping outside the building, we don't lose any of our engine coolant. So on the primary side, we're connected into the engine coolant. So we come off the hot coolant line, run through the heat exchanger, here's the pump that does the circulation, come back up and return into the engine coolant line, then it can go on back to the radiators. And this side of the heat exchanger will operate under normal conditions at the same pressure and temperatures as the engine coolant piping because it's tied directly to it. The system is shut off right now, so our pressure is down, but under normal conditions you would see a pressure of 3 to 5 psi, and you should see temperatures coming into the heat exchanger of maybe 180 to 200 degrees, and then coming out will vary depending on the amount of load that's on the heat exchanger. Now on the secondary side of the heat exchanger, this is the loop that goes out to the remote building. And again, we should see temperatures that are slightly lower than the engine coolant. So if the engine coolant was coming in at 190, we might see our hot glycol coming out of this side at say 185 or 180 degrees. And then it circulates, runs out of the building over to an adjacent building. Because it's a longer piping loop, we run it at a higher pressure. So this system right now, because it's cool, is only running around 20 psi. Under normal operating conditions, we should see it up closer to about 30 psi. It has a 50 psi pressure relief on it that would, if you over temperature the system, would blow off. So we'll go through some of the components in the typical system. So here we come through the floor. We have our main isolation valves where we go out of the building. And these valves are labeled normally open, waste heat supply, waste heat return. We come through a strainer here. This takes out any metal particles that could be in the piping system to keep them from clogging up the heat exchanger. Over here we have a pressure relief valve. This device, if we get overpressure on the system, will relieve and it'll spill glycol to the floor. And then we come around here, we have thermometers so we can monitor the temperature coming in and going back out. Pressure gauges. Now one thing I want to point out is on each pump we've installed a pressure gauge upstream and downstream, and that's how you tell that your pumps are operating. So typically the pressure, if the pump is working, will always be higher on the downstream end than it is on the upstream end. So here we have a pressure of about 18 psi coming into the pump and a pressure of about 27, 28 psi going out. Now if I turn the pump off, we'll see these pressures equalize. So now we have approximately 19 psi upstream and downstream. When I turn the pump back on, the pressures go back. So you can verify that each pump is operating through that. Now this system, because it operates at a higher pressure, has a closed expansion tank. So this expansion tank does not have a sight gauge on it. Over here we have a valve, which is our add point. And it's a different colored valve tag. It says normally closed, open only for adding fluid, propylene glycol only. Because this system goes outside the building, we use a different type of glycol, propylene glycol, that's non-toxic. Again, you have to make sure when you need to add fluid to the system that you use the exact same fluid that was installed, the same mixture, and again, you don't want to add local water to the system because you can clog up the heat exchange. Okay, this system also has an energy meter. There's a flow meter down here in the piping. And up on the wall here, we have a flow computer. And so what this device does is measures the amount of energy that's being sent out. So it records the flow rate and the temperatures and the energy sent. So you can use this if you're charging for waste heat. You can use this as your billing method. Okay, now in this system, the waste heat goes to a remote building, which we'll look at in a little bit. And we also come off the waste heat system and provide heat to the other rooms in the power plant, which we'll go through. So we have this small pump here, and this one serves the unit heaters in the control room and the storage room. And again, we can see that this pump is operating by turning the switch on and off and seeing the pressure gauge vary. Okay, in this building, the control room and the parts storage room are separated from the engine room, so they need supplemental heat. So what we have is a piping system off the heat recovery to a unit heater in each room. And just note on the unit heater, there are isolation valves where the piping comes through the wall so it can be shut off and serviced. There's a drain valve on the bottom to allow us to drain it down if we need to work on it. Then up on the top is an automatic air vent. And typically we leave these open until we get all the air bled out of the system, then we would turn it off. So that valve will need to be closed here to leave the system in service long term. The unit heater is controlled by a thermostat. When there's a call for heat, the fan will come on and it'll operate until the heating demand is satisfied. Now we're over at the water treatment plant where the waste heat from the power plant is delivered to. So here's where the piping enters the building. We have a valve, normally open valve, for the heating supply coming in. We have a strainer here, just like we had over in the radiator room, and we can see a good clear shot of it. The strainer has a drain valve on the bottom where if it ever gets clogged, we can open that up, blow down, and clear the debris out of it. We have a thermometer, pressure gauge, automatic air vent, which needs to be bled periodically. So the hot water from the power plant comes in, goes through this side of the heat exchanger, back out. And then on the other side we have the cool water from the building heat comes in through the heat exchanger and goes back to the boiler. And so we have normally open valves that are tagged, they just leave open. And really all you need to do on this is check it periodically, check the temperatures, make sure we've got adequate pressure. And this air vent we would normally leave in the valve closed off, and then we would open it periodically to bleed the air out of the system.